Okay, welcome back. I started recording already.
Okay, welcome to another episode of A-Level H2 Math.
And today, we're going to discuss on inequalities. That's right. Okay. Okay, first and foremost, right? Graph transformation, no problem.
No.
Hello.
Yeah, there's no problem.
You sure? 1 over fx. Did your school teach you f prime x graph?
No.
F
prime x.
You know what I'm talking about. Okay, let me show you.
Differentiated.
Yeah, like for instance, this one, f prime x. Like from fx, how do you get to f prime x? No? Yes?
No, I don't think they went through that. I haven't seen that before.
Okay, then all cool. Okay, so now we can go through inequalities question. You want to go through your school tutorial questions instead?
Yeah, but I don't know how to do it.
Yeah. Maybe you can take a snapshot and send me first. Then I can drag it onto the screen.
Okay.
Yeah. That was the best opening I've had so far. Like with you. I mean, like with the other people, it's like it just started very abruptly. But today's opening is damn good.
Because we are YouTube stars now.
Yeah. Later we have to think of a closing.
An outro. You want to play some music at the end?
Yeah, we should. Okay, like right now, right? Like right now, I should play a bit. Like, intermission time. You can hear, right?
Yeah.
And now it's intermission.
I sent 7 questions first. Yeah, like.
Okay, good enough. So you can eat while you listen to me, okay?
Okay.
Okay, intermission is over. Oh, but this is a nice song.
Yeah, it is.
Okay, back to the grind. Okay, for inequalities. So over, you can hear me, right?
Yeah, I hear you.
Wow, today you sound very, it's like very, your voice sounds very crispy today. Very good. I think
I'm
maybe
using
because,
a headset.
wow, no wonder lah.
My earpiece, the mic got a bit of problems.
I think you're like overpowering me now. Like your voice sounds a lot better. But it's okay. Okay, so now we want to solve this inequality. So how do you propose that we solve this inequality?
Factorize the x squared minus 9.
Sorry?
Factorize x squared minus 9.
Factorize x squared minus 9, how?
So like x minus 3, x plus 3. Then the x plus 3 cancel.
X plus 3, x minus 3. Right?
Yeah.
Can you cancel?
Can you, or just like leave it? Is it?
You cannot cancel. Why? because you will lose solutions. That is one. Secondly, you are unsure if the sign will flip. Which sign? I'm talking about this sign. Because when you cancel, right, what are people really doing when they are cancelling this? Okay, you have to go back to the fundamentals of math. When you are cancelling x plus 3, you are basically dividing both sides with x plus 3. Make sense?
Mm.
Yeah. When you are cancelling on both sides the x plus 3, you are essentially dividing both sides by x plus 3 so that you can cancel them. But when you divide both sides with x plus 3, how do you know whether x plus 3 is positive or negative? If it's positive, good news. Good for you. Everything will work out fine. If this x were to be something that is super small, like -8 or something, right? Okay. If this x will be something like -8, then you'll be in very, 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 very deep shit. Because this sign is going to flip. Because you're dividing by a negative number. So the fundamentals of inequality is that whenever you multiply or divide by a negative number, the sign will flip from this to this. Understandable?
Yeah.
Yeah, this is the reason why we cannot cancel it off. 明白吗？
Mm.
Okay, we can proceed now. So how are we going to do this? So let's say if we were to keep it, I mean, it's not let's say, we have to keep it, right?
Yeah.
So what should we do next? We are going to bring it to the other side. So we have x plus 3, x minus 3, minus x plus 3, x squared minus 3x plus 1 is greater or equal to 0. So from here, we'll take out x plus 3, right? We can factorize out.
Yeah.
Yeah, then we'll be left with x minus 3 minus x squared plus 3x minus 1. Right? Which should give us x plus 3. If we resolve this, we'll get minus x squared. We'll get plus 4x. We'll get minus 4. Right?
Yeah.
Yeah. So from here, I want to remove the negative sign over here first. Which negative sign? This one. Okay, you see the coefficient of x squared. There's a negative sign there. I want to remove the negative sign. So I'll
Can
be
you just can you just flip this in?
yeah, I'll be flipping it. So I'll get x plus 3, x squared minus 4x plus 4. Then I flip the sign. Right?
Yeah.
Yeah. Okay. So from here, what should we do?
I'm able to factorize x squared minus 4x plus 4.
How?
Like, use the calculator, is it? Yeah. So x minus 2, then, just x minus 2 squared. Yeah.
Yeah. So from here, okay, we know that the factors are, okay, the roots are minus 3 and 2, right?
Yeah.
Yeah. So if you were to draw a line, we'll have minus 3 and 2. And we want the part of the graph, that is positive, which means we are only concerned about what the above, the top part. We don't want anything that is below. But we need to know which parts are above, right?
Yeah.
Yeah. So what you can do is we can substitute some values in. When we want a value here, which is like, let's say -4, when x is equals to -4, okay, so we'll get -4 plus 3, -4 minus 2 square is equals to minus, sorry, my bad. We want it to be lesser than 0, not above 0. I mean, I drew wrongly. We want it to be here. We want it to be at the bottom. Okay, -4 minus 3 is -1. -1 times. So we get -4 minus 2 square, right?
Yeah.
Yeah, we already know that this one is lesser than 0. So this part here, all the way until -3, is going to be our solution. So we already know that x must be lesser or equals to -3. Understand? How do we know that we need to include -3? Because of the symbol here. There must be equal sign. 100% there must be equal sign. Okay, so anything that's in between here, -3 and 2, let's say we use 0, for instance. So when x is equals to 0, okay, so we get 0 plus 3, 0 minus 2 square, that's what equals to 0. Sorry, this will be equals to 3 times -2 square, which is equals to 3 times 4, equals to 12, which is greater than 0. This is not what we want, right? So we know that this part over here is going to be positive, and we don't want that. Okay.
Yeah.
So next, so we're going to choose something here. Let's say we choose 3. So when x equals to 3, we're going to get 3 plus 3, 3 minus 2 square, which will get 6, which is greater than 0. And it is not what we want also. Right?
Yeah.
But if you look at the solution, we have x equals 2.
What does that mean?
Which this means, right? Okay, what all these solutions mean is that, right, when x is lesser or equals to -3, right, it will fulfill this equation, this inequality. When x is lesser or equals to -3, this graph will be bigger or equals to this graph. When x is equals to 2, this graph will be bigger or equals to this graph also. Means the x squared minus 9 will be above or just touching this graph. But looks very complicated, right?
Yeah.
Yeah. Is there easier? So the question is there an easier way to do it?
Yeah. Wait, can we just tell that because since it's less than equal to 0, then all equations are actually like positive. Then x has to only has to be equal to 2.
X has to what?
Like because based on the equation, like 0 is greater than or equal to
correct. We can also say that. So over here, although we show that this part is for any x values greater than 0 is positive, right? We will not get that. But because over here it says lesser or equals to 0. As long as it's equals to 0, we will be able to take that value in. So what you said was right. We can choose -3 or we can choose 2. That's why here we included -3. So we can include x equals 2 also.
Okay.
Yeah. So the question is like, can we not go through all these steps to do it or not? Right? I mean, we like shortcuts, right?
Yeah.
Yeah.
Is there a shortcut?
Okay. I recommend you to use this method. Sorry.
Oh, what's that? Draw a calculator.
Yes. This is the method. So you can just use the GC to plot this graph
Oh,
and this graph.
but that's like, isn't that like a graphical method?
Yeah, graphical method. But the thing is, did this question say that you cannot use your GC?
No.
No.
So you can just use that.
Yeah. Look at question 2. Okay, so for this question, you definitely can use your GC.
No, you can't. The question you cannot use that.
Yeah. So now we look at question 2. Hold on. Over here, can we use GC?
No.
Cannot. But can we use the GC?
Oh, like just plot the table thing. Oh, can.
Actually,
Just
we can use. Just that they
just
cannot
write it
know.
down.
Yeah, they cannot know. Okay. So for question 1, you can use the GC. Okay. 100% because they never say that you cannot use. So when you use, you have to use it by. So you say using GC, then you have to plot out the graph, sketch the graph out. Understand? Yeah. So for question 2, how are we going to solve this? So we have -2 lesser than 2x plus 3 over x minus 1 lesser than 1. So usually for this kind of double edge kind of inequality, right? How did your teacher get you guys to solve it last time?
-2. I mean 2x plus 3 over x minus 1 greater than -2, and then 1 greater than 2x
Very
plus 3
good.
over x minus
So
1.
you split, right?
Yeah.
So you split. So number 1, you use 2x plus 3 over x minus 1 greater than -2. Okay, we solve for this first. So how are we going to solve for this?
2x plus 3 greater than -2 and then x minus 1.
You mean this? Like that?
Yeah.
Can you do this? So this is the actually, are you eating now?
Yeah, but it's okay. It's
Never mind, you can eat as I go through. You can eat, yeah. Or maybe later we can take a 5 minutes break, then you can eat something.
oh,
Yeah. Never mind, but let me go through this question first.
yeah.
Okay. So a lot of people want to do this. Really, a lot of people want to do this. But the question is, can you do that? You have to understand what's the fundamentals of inequality.
Oh, you can't use it
Because you do not know whether x minus 1 is a positive or negative
negative.
number. We don't know. We don't know what is the range of values of x that we don't know what's the range of values that x can take. So if you multiply by x minus 1, wow, the sign may flip. It may not flip, okay? It may or may not flip, but there's a possibility that it may flip. So we cannot do that. We can only multiply by a positive number. How are we going to multiply by a positive number? So this is what I'm going to do. This is a foolproof method. Okay, I'm going to multiply both sides by x minus 1 squared. See? So from here, we can see that the x minus 1 can cancel out.
Yeah.
Yeah, because I multiply by x minus 1 squared 100%, this is to ensure that it is positive. Yeah, it's to ensure positivity. So next time, whenever you're feeling sad, right? You just put yourself into a square.
When I'm sad, I put myself into a square.
Yeah, then it will ensure positivity.
Oh.
I'm just trying to get more subscribers, maybe because like listen to some jokes on, during this in this recording, right? You feel like, hey, this guy quite funny.
Yeah. Content is content.
Yeah, content, just need to get the content out there. Yeah, so whenever you guys out there, if you are ever feeling sad, the only way, the fastest way to make yourself feel happier is to put yourself into a square, because it ensures positivity. Okay, I desperately need some audience to help me to laugh. I mean, like, if there's like a
Wait, I have. Wait, you just say another joke, then let me find.
later.
Okay. Yeah, I got it.
You got it, so you'll be
Yeah.
my DJ,
Yeah.
Okay, can. You're my music guy,
You know, like at the end of, like when you watch sitcoms, right? Then when
Yeah.
they make a joke, then
Yeah.
audience at the back laughing. Yeah.
Yeah. I know. Yeah, hold on.
Hello.
Yo.
Oh,
Okay, so you often multiply both sides by a square, right?
yeah.
Then you are left with 2x plus 3, x minus 1, minus 2x minus 1 square. Okay, then you bring it over, you will get your 2x plus 3, x minus 1 plus 2, x minus 1 square. Okay,
Yeah.
then what you're going to do is you're going to factorize it. You get your 2x plus 3 plus 2x minus 2. Okay,
Yeah.
you get 4x minus, sorry, plus 1. Okay, so from here you can use your, I think it should be either EMAF or AMAF method to solve this. Because you know that this is a smiling curve, right? How do you know that?
It's positive. Greater than
It's
zero.
positive. Correct, very good. So you're going to draw this thing. Okay, a smiling curve with a line intersecting through. So what are the roots of this curve?
X equals to minus 1/4 and x
Minus
equals
what?
to 1.
Yes. And we want the part that is greater than
0.
0. And which is the part?
The one's like behind here, yeah.
Okay, so we will have x lesser than minus 1/4 or x greater than 1. Very good. Okay, I think we use up quite a bit of space here already. So I'm going to write the solutions here. This is for solving part 1. Then after that, we will proceed to go and solve part 2. Okay? So for part 2, we will be, for the part 2, we'll be solving this. Sorry, it's very ugly. Let me rewrite this. I mean, we need to be professional, you know. Now we are on like national TV, international TV.
Yeah.
With
Front of
190
millions of
views. Yeah. In front of the whole Singapore's A-level cohort. No, there are people from everywhere watching us right now.
Yeah. Do they watch the entire like 2 hours?
I'm not sure lah, but
Or 1
I
hour?
mean usually people who want to watch, maybe they will just catch the important parts. Like because in every video I will write what was discussed in this video.
Oh yeah.
Yeah. So like they will just like try to fast forward. Because the good thing about YouTube is that you can select the playback speed. Like you can be 2 times faster or like 1.5 times faster or even make it slower.
Yeah.
Yeah. So from here, we have 2x plus 3 over x minus 1. So you have to do the same thing again, right? Because we do not know whether x minus 1 is positive or negative. Make sense?
Yeah.
Yeah. So why not you try this and show me, then you send me the solution. Do you have your tablet yet? Do you have your stylus yet?
No.
Yeah, shit lah. That day I should have passed it to you.
You might use my finger, right?
Finger, not professional.
I think I want like normal stylus for phone kind. I can also use it.
Yeah, those kind of.
I need to find. I haven't found it.
Okay, I think it's time to find it after this recording.
Yeah.
For the sake of our viewers. But right now, right, the alternative plan is that you do it on a paper, then you send me on WhatsApp, then I will drag it out. So you can prove your competency to our viewers here.
Yeah.
But I honestly don't know why most of them watch the graph transformation video.
Wait, that's the only one that got like a lot of views, 100 plus.
I think so.
Oh. Oh my god. It's can't be me. I'm so stoned doing the recording.
You sound a lot more energetic today. Okay, Mark, quick. Show me this first.
Okay, I sent it to you already. I sent it to you already.
Yeah, I know.
Oh.
Okay. So everyone, this is Gregory's piece of work. Let's see if it's correct. Okay, so he managed to copy it successfully. Multiply by square on both sides. Okay, then transferring it over to the left hand side. Factorizing. Leaving 2x plus 3 and minus x plus 1. He multiplied negative and converted the negative to positive over here, which is correct. Then you're left with x plus 4, which is correct. So by drawing the graph, you will get minus 4 and 1. So it is between minus 4 and 1. So you're going to get, yes, this is perfect. Okay, so now we have one solution here, we have another solution here, and we have another solution here, right? So in the event where you have two or more solutions in inequalities, it is essential that you draw the number line. You there?
Yeah.
Yeah. So what we have here is we have a minus 4. Hold on. We have a minus 4. We have minus 1 over 4. We have 1. Oh, that's all, actually. Okay. So what we want to do now is to find the intersection. So we have from minus 4 to 1. And we have x lesser than minus 1 over 4. And we have x greater than 1. So we have to find the intersection. Where is the intersection here?
Oh, the bottom and top arrow for the first one, the first arrow. I can just annotate, right? Yeah.
Yeah. So this will constitute our solution. So our solution will be from x between minus 1 over 4 and minus 4. Okay?
Yeah.
So this is how we find it, huh? Okay, next question.
Wait, that's it. So,
Yeah.
oh, okay.
Okay? So the
Oh,
intersection will
so
be the
just
answer.
wait, so we just draw the arrows and then see where it intersects and then
Yes,
that's our
correct.
range.
Correct.
Mm,
So the orange part is where is what we want. Right between this one. Because we need the intersection, you see.
wait, but how do you know where to draw the arrows again?
Where to what?
Where to draw the arrows?
Where
Just just okay,
because
never mind, I got it. Yeah,
okay.
just follow the range. Yeah.
Yeah, it's okay. I think that is a good question. Some of our viewers will have that question as well.
Okay, yeah, I got it.
Yeah. Thanks for enlightening them. Okay, let's move on to the next one. Okay, see, so far only the first question we can use graphic calculator.
Yeah.
Okay. It is given that, okay, now we have something interesting already. We have to break down the question first. We always break down the question. We have this nonsense here. Okay. And we know that x cannot be 1. Why? Because what?
Oh wait,
Because
my
what?
screen is. Hold on. Wait, oh, because we don't know whether it's positive or negative.
No.
Like,
Why x
X
cannot
must.
be? There's no.
Oh,
There's
oh. Wait. Okay. Yeah, wait. Sorry, what's the question again?
huh?
Why x cannot be equals to 1?
Yeah. Why x cannot be 1 over here?
Oh, because it'll be 0. The denominator will be 0.
So what if the denominator is 0?
And there's no equation, like, no solution.
If the denominator
Math
is
error.
0, yes, math error. Okay. Always remember, you cannot divide by 0. Just imagine I ask you, I give you a piece of bread. Hey, go and divide with 3 people. Hey, go and divide with 0 people. You'll be like, huh? What? Why? Like, give me a piece of bread. Ask me to divide with 0 people. Go and share with 0 people. How to share with 0 people, man? Right? You'll be in a confusion. That's why your calculator will give you math error because the calculator doesn't know how to process it. Okay?
Yeah.
Then next, without using a graphing calculator, find a set of values that y can take. Hey, sounds very familiar, right? We have seen this somewhere, right?
Yeah.
Where have you seen this before?
Set of values.
We have seen this question before, right?
Wait, was it just the previous question?
In the previous chapter, curve sketching under conics.
Oh, yeah.
Right? Because
Yeah.
remember when we see this, what kind of conic is this? We have 3 different kinds of conic. What are the 3 main kinds?
Circles, ellipse, parabola.
Yes, circle, ellipse, hyperbola. So which one is this? I mean, there is also parabola lah, but for parabola, we don't really, it's too simple. This was in A math or E math. We don't really test that right now. So which conic is this?
Wait.
Okay, it should look something like a hyperbola.
Oh, because of the
Okay.
oblique, is it?
Yes, because
Yeah.
we know that there will be oblique asymptote. Very good. How do we know there's oblique asymptote?
Because the degree in numerator is greater for x squared and x
How much higher?
by 1.
Can it be 2 degrees higher?
Uh, it can.
Cannot. Go and look at the cheat sheet that
Oh,
I gave you.
wait.
It cannot be 2 degrees higher. It can only be 1 degrees higher.
Yeah, only 1 degree. Yeah, sorry.
Yes, only 1 degree higher. Okay, so upfront although they say cannot use a graphing calculator over here, but I mean, you can do anything, but just don't get caught, right? So we can still use the graphing calculator to sketch the graph. It's just that we don't plot it out. Okay. So over here, upfront, we can do we can find what is the vertical asymptote. The vertical asymptote will be
X equals to 1.
it will be x equals 1, right? Which is
Yeah.
somewhere here. Okay. Then after that, we want to find the oblique asymptote. How to find the oblique asymptote? We have to do
Long division.
yes, long division. Can you do it for me?
I do long division and send to you.
Don't have to send to me lah. This one don't have to send to me. Just
Oh,
tell
so
me
just,
what is the quotient. Because the oblique asymptote will be in the quotient.
oh, okay. So x on top.
You do and tell me. I trust you.
So oh, okay, wait. I just annotate, is it?
Don't have to annotate. You don't have a stylus, so you do on the paper, then you just tell me the answer.
Oh, okay. What is it though is x plus 3.
What?
X plus 2, sorry, x plus 2.
So it should look something like that. Right?
Yeah.
Okay. So the graph would be something like that. Or it can be something like that. Make sense?
Yeah.
So now we want to find the set of values that y can take. Okay? We want to find a set of values that y can take. So where are the y values? Where are the values that y can take? Okay? If you look carefully, it's basically here. From here upwards.
Yeah.
And from here downwards. Make sense?
Yeah.
But how are you going to find that? This question is in the inequalities tutorial.
Yeah, so solve an inequality.
We went through this before. When they ask you for set of values that y can take, you always use this thing.
uh, substitution, is it?
Wrong. Guess a letter.
Uh, wait. This is so very. Wait, what is it?
Guess a letter.
D or L? Oh, differentiation.
Wrong. You can do that. You can do differentiation also. Because when you do differentiation, right? You'll be able to get these points. The maximum and minimum point. You can do that. But that's not the advice method.
This. Oh, discrimination. Oh yeah.
Discrimination? You want to discriminate who?
This. Oh, discriminant.
Hey, dude, we did this question before, right?
Discrimination. That's stoning, yeah. Discriminant.
Hello.
Yeah.
We did this question before, right?
Yeah.
Yeah, use discriminant. Because now I want to find the set of values that y can take. So basically, right now I want to draw a graph of y equals to k. Remember? I want to let y be equals to k. Okay, I want to introduce this new arbitrary horizontal line, y equals to k. Then from there, I want to equate it to this equation. Because I want these two graphs to intersect. Agree?
Yeah.
Yeah. Remember this method or not? I want to introduce, okay, I repeat, I'm going to introduce a new horizontal arbitrary line, which is y equals to k. I don't know what is k, it's my job to find out. Because these values of this k here will be the set of values that y can take. Because the y in this case is k.
Yeah.
Yeah,
Oh,
we
shit,
want
I
it to
forgot
intersect.
how to do that. I forgot about this
Okay.
method.
So from here we have x squared plus x plus 1 equals to kx minus k. Then from here, bring it over, x squared plus x minus kx plus 1 plus k equals 0. So we have x squared plus 1 minus kx plus 1 plus k equals 0. So from here, we can do our b squared minus 4ac to be, since we want it to intersect, right?
Greater than 0.
We want it to be greater or
Equal
to 0.
Equal to 0.
Because the line can be at this point as well. Just nice touching it. It can be at this point as well.
Yeah.
Get it?
Yeah.
So by solving this b squared minus 4ac, you will be able to find the set of values that y can take. Okay?
Wait, what does the x subset of R mean?
Sorry again?
What does the x subset of R mean?
X subset of R? Where got?
The one beside the x not equals to 1.
Oh, you mean this thing?
Yeah. How we
This
see
doesn't
that?
mean subset. X is an element of all real numbers. X is an element of all real numbers. Means X can take on any value of real numbers.
Oh.
It's not subset. Subset is written like that.
Oh.
Understand?
Oh. Yeah. Wait, then must we include that in our answer? The Y is element of R.
Don't have to.
Okay.
Don't have to. And this is the reason why. This is the reason why this question is included in the inequalities tutorial, because you have to solve the inequalities.
Oh.
Okay. So I think you already know how to solve inequalities already. It's either you do by algebraic way or graphical way. But the thing is, over here you cannot do by graphical way, right?
Yeah.
Because they say without using. Make sense?
Yeah.
So you should be able to solve this question already. Are you clear? If you're not clear, I can re-explain again.
I got it.
You sure? Ah? But
Yeah.
the most important part about this whole question is this part. It's
Yeah,
about
I forgot my
introducing.
scrivener.
Yes, it's about introducing this horizontal line. Which horizontal line? This one. This one. This one. Okay?
Yeah.
Can I? Okay, so if so, maybe we can take like 5 minutes break.
Okay.
Okay?
Yeah.
You can go eat something first.
Oh, okay.
So see you at 2:25 p.m.
Okay. Can you hear that? AUS, man.
Yeah, thank you.
Oh.
Thank you. Okay, see you at 2:25.
Okay. Hello.
And welcome back.
Okay.
Okay. Damn, it's been a long day.
It's not over for you, right?
It's not.
Huh.
So, how do you feel about the suspension of school? Happy, yeah?
Yeah, actually.
You must be celebrating, right, when they announced that.
Yeah.
Your mom say anything?
Mm, no, not really.
Oh, yeah, by the way, I sent your mom the video also.
Yeah.
Oh, you know, ah?
Yeah.
She told you.
Yeah.
Did she say anything about it? Because she,
She hasn't watched it yet.
because she was concerned that like you couldn't focus online.
Oh.
Yeah, that's why then I say that's why I sent her a video to let her verify. But I think you are coping okay, right? For the online
Mm,
lesson.
yeah, it's okay.
Okay. Okay, so we are done for this question already. Yeah?
Yeah.
Great. Next up. Okay, I think we should not be going through this question. This question is too simple.
Question 4.
Yeah, this question is too simple already.
Oh, okay.
Look, sketch the curve. You can use GC, what?
Yeah.
Right? Then after
Then
they say
solve it.
solve,
Okay, yeah, then no need.
use GC also. But just to recap, what is the vertical asymptote here?
Half. X equals to half.
Half. X equals half. Very good. What is the horizontal asymptote here?
Half also, right?
Yes, half also. Very good. Very fast, right? Can tell, right?
Yeah.
Yeah. Yeah. For those who want to know how he can understand the horizontal asymptote in such lightning speed, please contact me.
Oh, wait, oh shit. Yeah, okay. Not
Advertisement,
in time.
advertisement.
Everything. I cannot play that in time. Never mind, never mind.
Nice.
No, this is mainly used for sarcasm, right? Send that to be sarcastic.
It's a what do you Google? Sarcastic sitcom laughter.
No, I found your Instagram.
Oh,
It's meant to be sarcastic.
oh,
Like they always say it's funny, and then they just play the audio.
yeah.
So like if a joke fails, right, then you just play that.
Yeah. Okay, let's break down this thing. Okay, it's given that this. Okay, we have this graph. What can we tell about this graph?
Mm, is oh we can find the vertical the oblique right by
Very good. What's the vertical?
C x equals C.
C. What's the oblique?
We got long division.
Okay, do long division. So we'll do x squared plus
Mm,
0x minus 4c squared. Always fill in every single degree, even though it's not there. Okay, you know what I'm trying to say? Like over here,
Yeah.
this x squared term, this x term, this is constant term. I know there's no x term, but always try to fill it in. So we have x minus c. So multiply by x, I'll get x squared minus cx. You see, this is why this is important. Okay, hold on now.
Yeah.
Okay. So we have positive cx minus 4c squared. So from here, we multiply by positive c, we get
Actually, don't even need to do long division. Wait, just x plus c. Then, yeah, minus 3c squared.
sorry again.
Well, actually, don't really need to do long division, right?
Why?
Because you can tell it's going to be like x plus c, then the remainder minus 3c squared.
How can you tell?
No, I don't know. I just worked it out and I realized it. Chill, like very straightforward, I thought.
But also have to do long division, right? To find the oblique asymptote.
Yeah.
Yeah. C times C times C, so we will get positive. Oh shit, it's minus. My bad. Minus C squared. So this is gone. So this will be minus 3c squared. Okay, so we have an oblique asymptote x plus c. Can? Then after that, by sketching this graph, hence state the values of k. So how are we going to do that? Hey, give me 1 minute now. I need to charge my tablet. I'm going to get the wire.
Oh, okay.
Because my writing pad is running out of it. Hold on. Yep, I'm back. And state the values of k. So it's a hence question, right?
Yeah.
So hence means what? Remember I mentioned this before. Hence means
You have to use the previous equation. Have you
no.
solved something? The previous part.
Converting current expression to previous expression to use given result. This is what hence mean. So it say hence state the set of values of k for which this. So we have x squared minus 4c squared equals to k c minus x minus c. So converting this current expression, okay, this is the current expression. So how do we convert to previous expression?
use discriminant.
No.
Like,
How do we convert from this
like,
to this?
I'll just divide by x minus c.
Exactly.
Oh, I thought.
So now what do you want to find? You want to find this is your first graph, which is y1. This is your second graph, which is y2. They are trying to find the intersection of these two graphs that has two distinct positive roots. Okay, it must be two distinct and it must be positive. Understand?
Yeah.
Yeah. So you have to draw a horizontal line across this graph. Okay, after you sketch it, and try to find two distinct positive intersections. Understand what I'm trying to say?
Yeah.
Yeah. Very fast, we are already at question 5.
Yeah. Actually, very fast. Lessons about to end. Oh, are you gonna extend a little bit more?
Yeah, we're going to extend. You have lessons after this?
No.
Yeah, lor. We'll be extending. Okay, so you will touch this up. You will touch up this answer on your own when you're doing a tutorial.
Wait. So after I draw the line to find the two distinct points, then
Because it's a state question, right? It says state the set of values of k. So from the graph itself, let's say if this is the graph, there will be a line y equals to k is a horizontal line, such that there will be two. So let's say this is y equals k. So you have to find from here, or like from here upwards, for there to be.
wait. So you have to use discriminant.
Because they say state. So when they say state, right, and then they have a hence here, means they want to you to use the graph. By right, you can use discriminant. But it's a hence question, right?
Yeah.
So you have to use the graph. That's why we convert the current expression to previous expression, which is this, so that we can use the given result. What is the given result? The given result is the graph drawn. Right? Must understand the setter's intention. Do you understand?
Yeah.
Yeah. Because by right, I know this chapter is on inequality. By right, we should be using inequality. Then over here, we use b squared minus 4ac. But I think maybe your teachers identified I think your teachers identified this setup wrongly. They shouldn't have put it under inequalities, because you cannot use inequalities to solve here. You have to use the previous part, which is the curve sketching.
So how do I even find the points?
Okay, now why don't you sketch your curve first?
Mm, okay.
They say c is a positive constant, right?
Yeah.
Yeah.
So after I sketch the graph, then draw the y equals to k, such that it cuts two distinct points.
Yeah, you don't have to draw the y equals k over it. As in,
Or just
it is
no.
your job to understand, right? What are the values of k? What are the values of k? Which the horizontal line will span from which from which range, such that it will cut at two distinct points with positive roots.
Wait, but how do I get an answer afterwards though?
Okay. So if the graph looks something like that, right? Because firstly, I'm not sure whether it will cut here. I don't know where it will cut. So you have to find the x-intercept. So it'll be like when y equals to 0, then you have x squared minus 4c squared over x minus c is equals to 0. So x squared minus 4c squared is equals to 0. So you have x minus 2c, x plus 2c equals 0. So you have x equals to 2c or x equals to minus 2c. Oh, so just nice. One of it will be positive, one of it will be negative. Right?
Yeah.
You see what I mean? One of it will be positive, one of it will be negative. Positive, negative. Because one is 2c, one is c. So
Yeah.
over here at this point, this will be minus 2c. Here will be 2c. So now if I want to draw a horizontal line across, now if I want to draw a horizontal line across, it has got to be from either from here upwards, right? To have positive roots. If you think about it, if I now want to have positive roots, this is positive, right? Then
Yeah.
this is positive roots, you see? No matter how I draw the lines here, I draw the line here, and draw a line here. No matter how I draw the line, it will always cut and give me positive roots. Make sense? Whereas for this other side of the curve, it will not give me two positive roots. Because this portion here, will give me negative root. Make sense?
Yeah.
Hello?
Yeah. Yeah.
Yeah. So we are only concerned about this portion of the graph. Because when we draw a horizontal line across, it's going to give us positive root. Hmm. So right now, what we have to find is this point over here, the minimum point here. Because the k will be from this value onwards. This y1 here. The k must be greater than this y1. It's just that how do we find this value?
Oh, they just maximum minimum, is it?
Actually, you can use maximum minimum. You can do dy dx. Actually, this question is not very. It's not phrased very well.
It's only 1 mark though.
Yeah, it's not phrased very well actually. Points of intersection with the
Why
axis.
is it greater than 4c though?
Hold on, let me take a look. It says state. If it says state means by right, if it says state, right, just by looking, we should be able to tell this point. But now we can't tell at all. How can we tell that? How can we tell that point? Unless we do discriminant, no. Then like that there won't be a point in. This question is very badly phrased. I can only say that. Because if they want us to do discriminant, straight away we can get the answer already.
Yeah.
Right. X minus c equals to k from here. But I don't think so. I don't think we should be doing discriminant. But this question is placed under inequalities. But right, if it's placed under inequalities means you want us to do discriminant. So weird. We should be getting equals to kx minus kc x square minus kx plus kc minus 4c square. b square minus 4ac to be greater or equal to 0. Since it says this, b square minus 4ac to be greater than 0 because it says two distinct. So we are going to have k square minus 4 kc minus 4 c square k square minus k c minus 4c square. Oh my god. Doesn't make sense. It's only 1 mark. We should not be doing by this way.
But how do you even get greater than 4c? I don't understand that.
It's our job to understand it. Let's try to understand it. Every problem was created with a solution. I think today's progress quite power. We reach question 5.
Really?
Yeah. C is a positive constant. We use cannot be dy dx, right? It says state. State means by right no workings required. So weird. How are we going to find the how are we going to find this point? We just need to find this point.
You can't maximum minimum, is it?
Cannot. I mean, we can, but the thing is, of course we can, but it says state. State means by right you should not be using any you should not be using any, how you call that, any workings.
Like, don't let them know.
Don't let them know. Also can. Also can. You can do that. You can do dy dx. You do dy dx, then it equals to 0. You should have two values. Why you have two values? Because you have this point and this point. Right?
Yeah.
Yeah. Then after that, one of the value, find out for d2y dx square, which value is lesser than 0. Because that has to, sorry, which value is greater than 0? Because we want to find the minimum point. Right?
Yeah.
Yeah. So once you find that x value, you'll be able to find the y value. I don't see another way out. This is definitely the most promising way. But just by looking, because it says hence state. Okay, never mind. We can have this question first, but this will be how we want to work it out. Maybe the solution booklet that your school provide will also use this method. We never know. Okay.
Wait, so after that, then how do we get 4C?
Yeah, you do dy dx equals 0. You will have two values of x, right?
Yeah.
Yeah, because you got two stationary points. After that, you have to substitute the two values of x into the d2y dx square. So one of the values should give you a positive answer. And a positive answer, with the positive answer, which also means it's a minimum point, which is what we want. Right?
Yeah.
Yeah. So once you get the value of x, you substitute into this equation. After you substitute the value of x in this equation, you should be able to get your y value, which is this. Do you understand?
Yeah.
Okay. It's just that, I mean, this is an alternative. I'm not sure what is the main method to actually visually be able to state. Because it mentions state, the set of values of k. I wonder how.
I can wait for the solution to come up.
Yeah. Never mind. We move on to the next question first.
Yeah.
Okay. Oh, this one. Oh, okay. Okay, look here. You there?
Yeah.
Yeah. So sketching the graphs, no problem, okay? Right?
Yeah.
You can use your GC to sketch. Then it said hence. Hence, find the
Yeah.
exact range of values of x for which this is greater than this. Honestly speaking, right, the person who created this question, right, got issues. Okay? Because if you want to look, understand the setter's intention. They want us to sketch, then they said hence, means they want us to use the graph, right? Make sense?
Yeah.
But they said exact. Exact means cannot use graph,
Yeah. Yeah.
right?
That's why it's 5 marks, I think. Yeah.
Yeah, it's ridiculous. They say hence, but we cannot use the graph. So the person who created this question, I mean, he's suffering from some logic deficiency or something. Serious. It doesn't make sense. We ask us to sketch a graph, then it says hence, means they want us to use the graph, right? Understand the setter's intention, all right? Then they say exact, means cannot use graph. Am I right?
Yeah.
Yeah, ridiculous. Like, it doesn't matter.
Welcome to my
Let's,
school.
yeah. Okay, never mind. Let's try to solve this algebraically, okay? Okay. So you will see inequality. So this is another question setup. Okay. I will pass you a inequality cheat sheet. This is another question setup. Okay, where there is modulus involved in inequalities. Okay. When there's modulus, whenever there's modulus involved, we do not like it. We do not like modulus. We want to remove the modulus. Right?
Yeah.
Yeah, we want to remove the modulus. But the question is how? Okay. Let's say, for instance, if I have mod x greater than 1, how do I remove the modulus?
How to remove the...
Yeah, how do I remove modulus x greater than 1 and also modulus x lesser than 1?
Wait.
Give me 1 minute. Give me 1 minute. I'll let you think.
Oh, must there be like two equations?
Yo, I'm back. So how?
Must there be two equations, like for the x minus 10 square greater than x minus 3?
This one will be x greater than 1 and x, remember?
Less than 1.
Lesser than
Oh,
minus 1.
yeah.
Yeah. This one will be x between 1 and
Minus 1.
minus 1. Okay, usually how I do this, my go-to trick, right, is to always draw this thing. So when they say lesser than 1, I'll have 1 and minus 1 here. Since it's greater, right, means it's above. So same thing for this, I will draw this. Then here is 1 minus 1. Since they say it's lesser, then it will be below. Okay?
Yeah.
Yeah. So this is how we remove the modulus. So right now we have this, okay? X minus 10 square greater than mod x minus 3. Sorry, mod x minus 3 mod. How are we going to remove the modulus?
There must be two equations, right? So x minus 3 lesser than x minus 10
Yes.
squared, then x minus 3 lesser
Yes.
than,
Can you
or
show
greater
me?
than.
Can you show me? Do on a piece of paper and show
Submit
me.
it or send you?
Send me. Yeah, do
Wait,
it
I
and send
take a
me.
picture.
Yeah.
Okay.
Oh, you did it already?
No, right now I'm doing it.
Okay, okay.
So it's just that, wait.
You send me already?
Oh, wait, hold on, wait, nice. Wait, it's just like that, right? Wait, is it just like this? Only need.
Hold on, let me check. It should be. What is your negative sign? You should have a negative sign.
Oh, I thought I flipped the.
Or you straight away flip. Also can. Also can. Then you can solve from there. Then you can solve from there.
Okay, so just like normally solve it. Normally solve it.
Yeah.
Wait,
So
so
from
normally solve it for both, right?
yeah, for both.
Both. Oh, okay.
Yeah. Then you should get this and this. Can?
Yeah.
Yeah, should not be difficult. So we can move on to question 7.
Yeah.
And that will be our last question for the day.
Okay.
Damn strong. Damn strong.
No lah.
Not strong, man.
I made few mistakes.
I think quite strong, eh. Okay, let's see if there's any flaw in this question again. I'm very confused lah for the past two questions, the question 5 and question. It says state, then I don't know, man.
Now got hands.
Yeah, okay. Anyway, without using a calculator, solve for this. Okay. So how are we going to solve for this question?
So just inequalities are like uh uh x plus 5 on both sides times x plus 5.
You cannot do that. Remember, I mentioned already. Why cannot
As
multiply by x plus 5?
wait. No, not multiply. I mean not multiply. Like, wait. Oh,
Because you multiply by x plus 5, you'll be in very, very deep shit. You
no,
don't know
like
whether is it positive or
the
negative.
x. No, it's like the x plus 5 square.
Yes, correct.
Wait, are you writing it down?
No, I'm waiting for you to solve it.
Okay. Wait, must I draw the number line? I'll just leave it as
Which one?
for the first one.
It's
The
just like
x
that.
plus 5. The x plus 5 is like. Then how do I leave
For
the x plus 5?
x plus 5.
Wait,
Oh, this one.
yeah, I mean. If, okay, I think I just sent you. Wait, what do I do with x plus 5? Do you get a photo?
Yeah, I just got it. Oh, yeah. Sorry, I think I missed out something. Multiply. Oh, I made a mistake. Yeah, you have to draw number line. Okay, we use your solution. Okay, so you got this part, right? You got this part. Very good. So for this part, right? Okay, what we have to do is we have to draw a number line. Okay. So number line will be from x equals from -5, minus square root 3, and square root 3. So from here, we know that this is the one of the solution, right? Correct?
Yeah.
Yeah, there's another solution that we want. Okay, so we want this whole thing, right? This one and this one, right? We want it to be greater or equals to 0. Make sense?
Yeah.
Yeah, we want it to be greater or equals to 0. So we know that um, x is equals to negative becomes 0 lesser than -5.
Wait, how come the sign changed? It's not greater than or equal to. Must you just sub in like -6 to the thing?
Why you change the sign?
Huh? Oh. I mean, because I brought the 3x over.
Here should be greater or
So
equals
then,
to what?
yeah, but then I brought the 3x over.
No, okay. So over here at this step, right, you have your x plus 5. You have your minus 3x squared.
I think I skipped a step. Yeah, so the -3x squared plus 9 greater than or equal to 0. After I brought the 3x
Okay,
over.
after this step, right, we want to solve this equation. We want to solve it like as if it is an equation on its own. We want to solve this. We want to find all the roots. Okay?
Yeah.
We want to solve all the roots. After we solve all the roots, right, then we get minus 5, we get minus square root 3 and square root 3. Okay? So from here, what we have to do is, right, we have to do this thing, which is what your school will call the sign test.
Yeah.
Okay?
Okay.
Yeah. Your school will call the sign test. What does it mean by using the sign test? Means you will have to add in a value. Okay, let's say here will be minus 6. Here will be maybe minus 4. Here will be maybe 0. Here will be maybe 3. Okay, we're going to sub these 4 values into this equation.
Yeah.
Into this equation. Okay, to see whether it gives us a positive or negative value.
Yeah.
Okay, if it's positive, then it's good because it will fulfill this inequality. Means that that is the portion that we want. We got 4 different portions that we want to look out for over here. Which is this portion, this portion here, this portion here, this portion here, and lastly, this portion here. So we want to know, but I tell you, if you want to do the sign test, that would be very dumb. What you should do is, right, I will plot this into the GC. I'll plot this into the GC. So once I use the GC, I will be able to know how the graph cuts the x-axis, right?
Yeah.
Yeah. Then from there, I can just put my plus, minus, plus, minus, plus, minus. I don't have to really sub in values.
Oh.
You get what I mean? That'll be a smarter move.
Put the x plus 5, minus 3x plus 9 into the GC.
Yeah. Then from there, you will know
Okay.
how the curve will maneuver about the x-axis. Then from there, you know which are the parts that are above, which are the parts that are below. But you don't state using GC. Because what you need to do is to draw this number line, then after that put the plus, minus, something like that.
Then after that, calculate then values it. Then just add minus 6. Oh, okay, wait. So when I sub in minus 6, then it's greater than 0.
You don't have to sub in.
Yeah, plus.
You don't have to sub in. From the
GC.
From the GC, you should be able to tell which part is positive, which part is above the x-axis, which part is below. Then from there, you can just draw this number line and put your plus, minus, plus, minus.
Yeah.
Yeah. So you have your orange color and your orange and yellow color parts, right?
Yeah.
Yeah. So that will give you your solution over here. See it? Okay.
But how come one of them is just greater than the other one is greater than or equal to?
Because, can you include negative 5?
No.
Why not?
Wait. Because it's equals to 0. Oh, okay.
That's why.
But then for the rest, you can include the
Yes, you
equal
can.
then, right? Because
yes. How do you know when to include and when not to include? Just look at the denominator. The denominator will tell you what you can include, what you cannot include, because this is a hindrance. Okay?
Wait, oh, you can't let it be equal to 0, is it?
What do you mean?
Like, because when you sub x equals to -5, then the entire thing is equal to 0.
No, when I sub x equals to -5 into the original equation, into the original inequality here, this will be done really. Math error.
Eh? Oh, but then,
I know
I
you're
only
looking
use
at
my
this
GC
one.
to,
I know you're looking at
yeah.
this.
It's like I
But
use
this
my
is
GC
process
to,
equation. This is the process equation. This equation here is the main equation. This is king.
because I was using my GC to like sub in the values.
Yeah, no.
Because that's only to find the sign.
The original equation is always king. Look at the original equation and look at the denominator.
Wait, so I use the equation to find the sign only.
Which equation?
The sign test, for the sign test.
Yeah, use the GC to understand how the graph moves, then put your plus minus. But you say by sign, you can state by sign test, then you put plus minus plus minus. By using your GC, that is the cheat code.
Wait, actually, what's the point of the sign test then?
Is to understand which parts are above and which parts are below. Because now what you want is greater than 0.
Oh, so
Then when you do your
then
sign
just
test, you
be
will know which parts are above the x-axis, which parts are below. Above x-axis means it's positive, which is what we want now.
okay. Then
Understand?
yeah, so if I were to sub in negative square root 3 into the equation, then I'll also get it will become equal to 0. Then I can use the gradient equals 0.
Gradient.
Like no, if I sub in negative square root 3
Ah.
into the equation, then it'll be equal to 0, right? Okay, then
That's what you can include.
okay. Yeah.
Okay. Hey, by the way,
Yeah.
if not, we continue next lesson because I need to go already.
Oh, okay.
Can for part 2, for this the 2 more parts, right? You can try on your own, then you drop me a text.
Yeah, I don't understand the part 2 though. I understand part 1.
This one.
Yeah.
Can I drop you a text on WhatsApp? Because I got someone else to attend to.
Okay.
Yeah, if not, I'll be snowballing already.
Okay.
Can
Yeah.
I text you later. Okay.
Okay.
Bye bye. I'll send you the video later.
Okay, bye bye.
Okay, bye.